All right, y'all, today's lesson is on significant figures. This is a super important lesson because we are going to be using this concept from now until the end of the year when we are doing math in my class, which is a lot, okay? I will let you know that it tends to be a little bit uncomfy when we first get into it, but the more you practice, the easier it becomes. And trust and believe, I'll be giving you a lot of practice. You will need your notes handout today. There is a front page where we're actually understanding the concept, and on the back page, we're actually doing a lot of practice on the concept. So lots of fun things to get in here today. Since it is some math that we'll be accomplishing, you will need your calculator and obviously a pencil to write with. So let's get into significant figures. What is this that's going on? Okay, so what is a significant figure? Well, we've done a lot of trying to measure with accuracy and precision, okay? The accuracy of any measurement will actually depend on two factors. The first thing is the precision, or the tick marks, and what determines that amount that you can estimate past, right? We practiced in our measuring lab yesterday, reading our graduated cylinders, and we knew whatever the increments of the tick marks of that graduated cylinder, I would have to measure from there first, and then with my brain estimate one digit past that, okay? Yeah, how accurate my measurement is going to be is absolutely going to depend on the precision of whatever measuring instrument I've chosen, right? The second thing that your accuracy depends on is the skill of the individual taking the measurement. If you're like messing up and not really reading things correctly or caring to read things correctly, you ain't got no skill in measuring things, and you're probably not going to have a very accurate measurement. Okay, so just when making measurements, we know we always read to the smallest marking of my tick marks on that instrument and then estimate another digit beyond that. So that's a review of kind of what we've been learning so far. Where does significant figures come into this? Well, a significant figure, or sig figs as I like to call them, they are the digits of a number that are used to express it to the required degree of accuracy from the first non-zero digit of the measurement. You were like, wait, what does that even mean? I agree, that is a wackadoo concept, okay? So slow down, just do not freak out. Let's break it down. Rules for counting sig figs in a number. So basically all of the numbers that you see, all the digits that you see in a number, some of them are what is called significant and some are not. That all leads back to the precision of our measuring instruments. Now there are some rules, okay? There are actually 3 rules, and you are so lucky because the first 2 rules are like way easy. The last rule is the only one that's a little bit hairy and weird, but is okay. We can do the hard things, can we not? I hope so. Okay. So our first rule is on non-zero numbers, meaning a counting number 1, 2, 3, 4, 5, 6, 7, 8, 9. Our second rule is just kind of explaining that in terms of scientific notation, or numbers put in scientific notation, how many sig figs there. And the last rule is dealing with my zeros, and you can kind of see we got a lot of things coming down here. So let's tackle the easy ones first. Okay, so the first one is for non-zero numbers, meaning numbers 1 through 9. Y'all, they are only significant, okay? So I see the number 911. There are no zeros in there for me to be confused by. Boom, boom, boom. That 9 is significant, the 1 is significant, and the next one is significant. So the total number of sig figs in that value is 3. Okay, so that is an easy rule. I really like that rule. Let's go on to the second one. The second one says numbers before the times 10 to the whatever in a measurement expressed in scientific notation. Y'all, they always significant, okay? So you can put your thumb and cover it up. Oh my gosh, okay. Whatever is in front of the times 10 to the, they all significant, okay? So that 6 is significant, the 0 is significant, the 2 is significant. So there are 1, 2, 3 sig figs. Same thing on this one, 3.00 times 10 to the 8th. I don't care about the times 10 to the 8th. Everything in front of that scientific notation totally is sig figs. So once again, 3 sig figs. Easy peasy. Let's get to the next rule. Do not freak out. There are 3 kind of conditions on if I'm determining if zeros are significant or not. I first focus on zeros that are leading, meaning zeros coming in hot on the left of my number. Then I have sandwich zeros, meaning zeros that are in between 2 other values, 1 through 9. And then I have ending zeros, meaning zeros that end a number, okay? So there's like 3 different categories based on the placement of my zeros. Okay, first one, leading zeros are never significant. Leading zeros, anything to the left. I see a bunch here coming in hot before I get to the first number or digit that is a 1 through 9, okay? oh, but there's a decimal in there and that freaks me out. Do not be freaked out, guys. I do not care if your leading zeros are before the decimal, after the decimal, on top of the decimal. I do not care. But if they are coming before anything that is a 1, 2, 3, 4, 5, 6, 7, 8, 9, they are not important. Never. And what I like to do, so I don't get too confused, I'm reading a book, anything that 0, 0, 0, 0, get rid of them. Now I stop because I've come to my first number that is not a 0. We know that all non-zero numbers are significant. So the 3 is significant, the 2 is significant. I got 2 sig figs in this number. Amazing. So leading zeros, none of them are. Okay, sandwich zeros. They're always significant. So I'm looking here, 8006. Y'all, I know that 8, I know that 6 is totally going to be significant. And my zeros are in between 2 non-zero numbers. They're sandwiched, so they will always be significant. So I have 1, 2, 3, 4 sig figs. Okay, this is where it gets weird. If I have zeros that end a number, meaning that follows the very, very, very end of my number, there is an issue that I've got to tackle. All I ask myself is, okay, is there a decimal in the number? If yes, all of them at the end are significant. If no, none of them at the end are significant, okay? So ending zeros are only significant if there is a decimal in that number. You're like, okay. All right, I'm looking at this. I know the 2 and 3 are significant. I don't even have to think about that because they're not zeros. Got zeros, okay. They are ending my number. If I'm ending my number, is there a decimal? No. That means they are not significant, okay? So I only have 2 sig figs in this number. The next example, slight change. Of course, my 2 and 3 are significant, but ending zeros. Now is there a decimal in the number? There is. So that makes those 2 zeros significant. So I have 4 sig figs in this value, okay? So that's the main difference between this. I have a decimal in the number. Oh, it gets more fun. Okay, next one. Oh my gosh, even more slight differences. You were like, oh my gosh, there is a decimal, but now that some are before, whatever, but on top, in the end on the decimal, it doesn't matter. I don't care if those zeros are before the decimal or after the decimal. If they are all ending a measurement value, all of them are significant because there just is a decimal in that number, okay? So yeah, the 2 and the 3, and all of those guys there at the end, all of them, because there's a decimal in that number, are significant. So I have how many? Let me count. 1, 2, 3, 4, 5, 6 sig figs. Amazing. All right, next one. You were like, oh, I'm freaking out. No, no, no. We've got kind of some things to look at. I totally see some zeros leading into that number. Oh, nothing leading into a number is significant. My leading zeros, nope. I hit a 2, I hit a 3. We know they're significant, and I have a trailing 0. You're like, okay, what's the rule for trailing zeros? Decimal, decimal, decimal. Is there a decimal in that number? Well, yeah, back here. Yeah, I don't care that it's back there. There's a decimal in the number, so your ending zeros, however many you have of them, are totally significant. Okay, so how many sig figs? That is 3 sig figs. And the reason why we're doing this, you guys, is when I take a measurement with, like, you know, a graduated cylinder or something, those tick marks allow for me to, with a certain level of confidence, estimate how precise that measurement is. That's what all of this business is showing here, okay? That decimal and any zeros that I have included after that lets me know that my measuring instrument allowed for me to have confidence in that, okay? If I'm not representing thing with a decimal and just kind of like 0, 0 at the end, who's to know what the precision of that instrument is? That could totally be just a really, really rough estimation. And if you didn't understand that, that is okay. Let's move on to the actual concept that we learned today before Ms. Tabaka gets too excited about why we were actually doing this. Because I get it. It's like, why are we actually doing this? Anyway, okay. So we're going to do some practice. I'm going to do a couple with you guys, and then we'll see if we can navigate some on your own while I kind of check with you on the side. Okay. The first one, y'all, I think is real easy. 12. I don't even see any zeros in that number. So both of those numbers are significant. Yay, 2 sig figs. Love it. Next one, I do have a 0 in the number, but he's snuck in between 2 non-zero numbers, right? So he's always significant. So 4.01 is 3 sig figs. Next one, 0.123. Okay, I got a 0 in the number. Leading, if I like to read these numbers from left to right like I'm reading a book, and if I hit any zeros in the front, get rid of them. Leading zeros are number significant, and then pick up any remaining non-zero numbers. There's nothing at the end that I have to be weird about, so I got 3. Okay, see if you can do the next one on your own. I'm going to be working hopefully silently behind. And remember, read it like a book. So I get 3 sig figs on that one too, leading zeros. I don't care if they're before, after, on top. They're never going to be on top, sorry. But they're all leading and they're never significant, okay? Next one down. See if you can do it on your own. Read it like a book from left to right. When you get to the end zeros, is there a decimal in the number? That is what is the deciding factor. And there is. So we have a 4 total sig figs. That one's a really good one. Okay, let's see if you can tackle some on this column, and I will work silently, I promise, silently. They're all 4s, which is very exciting. The main ones that I feel like were the trickiest one is anytime you see a decimal, those ending zeros, totally grab them. They're absolutely significant. And then the fun little rule of scientific notation, do not be afraid of the scientific notation. Covered up, everything in there will be significant, which is really exciting. Okay, so what are we using this for? She said, I needed my calculator today, and I can count 1, 2, 3, 4 like a kindergartner. I would not need a calculator for that. I agree. So we're going to go back to our PowerPoint real quick, and we're going to kind of be like, well, oh, there's some rules for using this in calculations. Okay, so rules for calculations with sig figs, y'all. I was like, what is she even doing here? I'm still waiting for the day that I will actually use this in real life. Well, in science, you will be using this every day when we make measurements. A lot of times when we do science, we take some measurements and we maybe like multiply them together, right? Or we maybe divide to get a different value from our measurement. So there are some calculations involving measured values, okay? So in science, we often do calculations with our measurements. When doing calculations, our answer cannot claim to be more accurate than the original measurements. You were like, what is even happening here? Well, to kind of like break it down, and I feel like I'm gonna go on a little quick tangent, is if I have a really imprecise measuring tool and another really imprecise measuring tool that I get 2 measurements from, and I multiply them together to get something different, yeah, your calculator may have a really long number with a lot of numbers after the decimal, right? It may not round to a perfect whole number. I can't have all of that stuff, which would express that, oh, I'm super accurate or precise, when the numbers coming in just were not from very accurate measuring tools. Okay, so you're like, okay, she needs to stop talking. We need to get what we want to do. Okay, so let's get down back to the document camera and kind of do this together on our paper. Now, in calculations, we're either adding or subtracting or multiplying or dividing, okay? So in adding and subtracting, that one actually doesn't have to do with sig figs. It's a little bit easier, so we'll zip through that first. It's also not as common as multiplying and dividing in my class, so you'll probably encounter the adding and subtracting rule less. But multiplying and dividing is super duper important, and that will use the concept of sig figs. Okay. So let's get to the first one. Adding and subtracting. When I add or subtract numbers together, it says the answer must be rounded to the same place value, meaning tens, hundreds, tenths, hundredths places, okay, as the measurement with the lowest precision. Okay, so let's pretend I'm adding together 2 of these numbers. Like this is like maybe 3.75 centimeters plus 4.1 centimeters. These are measured value. However many numbers I have in there included is gonna give me an idea of what that measuring instrument's precision was. So according to this rule, if I have a number coming in here, which y'all, it goes to the hundredths place as its lowest precision. And so we can write hund. Y'all get it, hundredths place. But my other value in here, it only has a value here as my most precise value in the tenths place. Well, when I get my final answer, if I type it up in my calculator, it gets me 7.85. Well, yo, you guys, I have to round my answer to the value going in that had the least number of significant place values, which is the 10th place. So the number in the calculator that is in the 10th place is this 8. So we get excited. I don't care about anything after that 8 right there. We stop there, except if the number sneaky behind the 8 is a 5 or higher, we know that we need to round that 8 up to a 9. So I'm looking here at that 5. Oh, we have 5. So that 8 rounds up, right? And that means it becomes 7.9. So I've chopped off that number in the 10th place, right? Which was the least precise measurement going into that. So I do that for adding and subtracting. So I kind of want to just bounce to the back here. I kind of did something weird. And on the remainder section, which is dealing with this concept of calculations, I feel like I should have mixed up some adding, subtracting, multiplying, dividing all together, but I did not do that. So the first 3 and only the first 3 are dealing with our adding and subtracting rule. So I thought maybe we would just like do that now and then focus on the more tricky ones. Okay, so this is when I add or I subtract. The way I like to think about it when I add and subtract, my rule for rounding is my place value, which means the number going into it with the lowest significant precision for that place value is where I chop my answer to. Okay, too much talking. Here we go. Okay, I see I'm adding. Okay, adding and subtracting place value, place value, place value. What is the last place value on this number? It's the 10th place. All right, this one, what is the last place value in this number? It's the 100th place. The least precise ending place value is the 10th place. So when I get to my rounded answer, I know that that's where I'm going to stop. I feel like I went too far. On this page, though, just to give you a heads up, there is a column for you to write a calculator answer. That means exactly what your calculator gives you. So if you need to have that committed down to paper to manipulate and then round, I have offered that for you. If you do not need this space at all, that is super duper fine. By the time you get to the end of the year, you will be able to do most of this stuff in your head. But I thought I'd give you all the option of doing this. I talk too much. Okay, so let's type this in our calculator. 121.4 plus 1.01. So if I enter that in, that's exactly what my calculator gives me. So I'm actually going to write that down. Yes? Okay, so that is the thing I'm trying to round here. We said we needed to chop it off at the 10th place. Well, that's the 10th place, meaning I do not want that one. That one is also not a 5 or higher, so I chop it 1, 2, 2.4. Yes? Amazing. Okay, next up, let's do the next one. Oh, my lowest precise place value is the 10th place here. And whoa, what is this? 1,000th place here. I don't even care that. That's a lot more over there. I know I have to stop my value at the 10th place. Let's grab my calculator and 212.1 plus. Oh, no, it's not plus, you guys. Oh, I almost got myself. It is what? Subtraction. Amazing. So minus 89.342. Cool. So my calculator gives me this, which is really funny because it's very similar to the last number that we got from a calculation. Okay, so it's got all that stuff. I got stuff extended to the 1,000th place, but nope. My least precise value going in was the 10th place. So just like last time, I'm stopping it there, but it will not be 122.7. It's going to be 122.8 because thank you to the 5 behind. Do the next one on your own. I will work silently behind you and we can check our answers to see how smart we are. All right, so yes, we had to round our answer to the 1,000th place because that was the least precise place value going in. Cool, so that's the adding and subtracting rule, and as I said, it's least common. So we've had that conversation. Now let's get into the multiplying and dividing because that actually does depend on the sig figs and counting sig figs like we practiced doing earlier. Okay, multiplying and dividing. Oh, the rules for multiplying and dividing is the answer must show the same number of sig figs as the measurement going in with the least number of sig figs. You're like, okay. Well, guys, we practice counting sig figs. Remember here on the back, y'all were great at that, okay? We're just going to do that for all of the numbers in that calculation, okay? So here we go. I notice this is division, so my brain is thinking sig figs. So what I like to actually think is for adding and subtracting, I'm looking at place value, PV. And multiplying and dividing, I'm looking at sig figs. That helps me to remember. Okay, so I'm dividing in fun stuff, and if I take 9.40 divided by 16, I'm going to get that. My calculator spits that out. But I'm dividing, which means I count sig figs. We are going to, just like last time, count the number of sig figs in this number. Oh, I've got an ending 0, ending 0, ending 0. The rule is for ending zeros that they are significant if there's a what? Decimal in the number, and there is. So this guy has 3 sig figs, okay? And I'm dividing it by 16. That one's real easy because there is no zeros for me to consider at all. So 2 sig figs. Oh, my least significant value going in is the one with the least number of sig figs, 2. That means I need to round my answer to only 2 sig figs. There you go. Be careful reading it like a book. I don't care about nothing that comes before something that is a number 1 through 9, okay? So that's 0, not important. I want to take only 2 of them as I'm reading a book left to right. Grab the first 2. Everything else is not important unless it is a 5 or a greater, which then just tells you that you're going to have to round that last sig fig of an 8 up to a 9. Yes? So the key thing here is that your answer needs to have the same number of sig figs as the least significant value, or the value with the lowest number of sig figs. So now let's flip to the back. And I give you the remainder of the problems on here as being the multiplication and division problems, because they're like super duper fun and something that is enforcing a new concept. So I like to think multiplying and dividing, we're looking at sig figs. Cool, 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 cool. Okay. Yeah, okay. So noticing they're all multiplying and dividing, because the tricky thing is I may give you something mixed up, multiply, divide, subtract, so you have to kind of switch your brain. Is this multiplying or dividing, or adding and subtracting? And it is multiplying or dividing for all of these. Okay, so once again, space to write your calculator value to where if you need that written down, then you can manipulate it and write your answer. But I'm only really looking for stuff over here. Okay, so we're going to go ahead and just put in that calculator answer real quick, and then we'll have the conversation about the sig figs. So I am multiplying. So I have 81.25 times 0.0014. Very cool. So that's what my calculator gives me. I'm going to write that down, just since this is our first example. Okay, sorry, I have a guinea pig like aggressively drinking water behind there, y'all. It makes lots of noise. Okay, so this answer that my calculator gives me, I have to round, okay? It all depends on the number of sig figs of both of these values going in. So I'm gonna count sig figs. The first value going in has got 4, because there are no zeros in that number to even consider. The second value going in, careful, those zeros, oh my gosh, they are leading in. Reading a book left to right, I don't care about anything until I get to the first non-zero number. So this one, there are 2 sig figs. That means I need to round that answer to 2, because that's the least. 0 is not significant. Your first sig fig that you get to is this one. I need to grab him, and I need another one to give me 2 total sig figs. That one. Okay, so I stop there. Everything else goes away. I do not need to round that last one up to a 2 because the 3 is not telling me that I need to. 0.11. Okay, cool, 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 cool. I actually am going to do this next one with you because it's a fun one. This is a really fun one. Okay. Oh, I'm getting excited. Okay, let's do this. Yay. Okay, so I'm dividing. So I'm going to type on my calculator and see what I get. Oh, this is a good one. I'm really pumped about this. Okay, 2.34 divided by 0.12. And my calculator gives me this 19.5. Oh, this is a good one. All right, I did division, so I count total sig figs. This guy's got 3 sig figs. This guy, that 0 is not important, so only 2 sig figs. You're like, great, I just need to round to the first 2 sig figs, start reading that book. Awesome, that means I immediately want that 1. We love that so much, and I want that 9. You're like, I love that so much, except the guy, I stopped there, right? But the guy behind him, oh man, he is a 5 or greater, which means I need that round that 9 up to a 10. And what do we do with math when we have to round up a 9? That spills over and means that I now get a 20 from that answer. And you're like, beautiful, I have 2 numbers there. That is my 2 sig figs. Careful. There is some sneaky business here with my ending zeros. Remember, Ending zeros are not considered significant if there is not a decimal in the number. So if you represented this value, even though you rounded like 19 up to a 20, like correctly, you can't represent it like that. If I saw that, that just means, okay, that zero she didn't think was significant. Well, I want you to know it's significant, so you actually have to do this really fun thing where you put a decimal in the number. And like magic, you guys, that is just immediately allowing that zero to be significant. So sometimes you can pop in a decimal if you need to use that to assist you in representing the true number of sig figs. That was a lot of talking. Okay, I think what I'm going to have you guys do is y'all can chew through the rest of these on your own, but I do want to pop down and do number 23, because number 23 is some scientific notation, and I thought it would be a great review for us to remind ourselves of our very special friend, the E button, which allows us to type in numbers in scientific notation without freaking out or getting confused or losing some numbers in the mix. Okay, so remember my scientific notation E button, right, takes the place of the times 10 to where you only have to write the value coming in before the scientific notation and whatever the exponent is, which is amazing, right? So this is your E button. So this would be replaced by E button. Cool, amazing. Let's go ahead and just type that in. It is a multiplication problem. So I go 1.35. Remember your second E is right there, so you activate it with the second key, and it'll actually pop up as 1E. I am not sure why, because like, why do you have a button with 2 E's if you can put one on my screen? It confuses me. It does not matter. I don't make the rules. Okay, yeah, I don't need parentheses, which is amazing. I can just blast on through and say times 3.840 second E, and then I have 4 is my exponent, correct? Did I do that right? Hopefully I did that right. We'll have to see. Okay, amazing. So I'm like, oh, cool, my calculator answer is super fun for me. I'm going to write 5.184. And that's it. You're like, that's it. I'm going to walk away. Woo, exciting. I'm ready to round, except you are not. Do not be freaked out, but you've got to make sure you read to the end of the calculator. And if you see an E, that means, oh, we got scientific notation number business here. That means I have a times 10 to the 10th. So we will have to include that as well. Cool. Now I just got to count sig figs because I multiplied these guys together. Remember with scientific notation, it's easy. Just grab anything in front of the notation part. So this number is 3. This number, all of them are important 4. The least number of sig figs going in is 3 sig figs. So I have to round this answer to 3 sig figs. So I grab, going from left to right, the 5, the 1, the 8. I stop there. Don't have to round that 8 up. So I go 5.18 times, whoops, you can't even see, 10 to the 10th. Yeah. Cool. So this is a concept we're going to be using all year. We do a lot of multiplying and dividing, and oh my gosh, you guys, you need to talk to the kids from last year because it is all sig figs from here on out, which is really exciting. But yes, it's all dealing with the precision and the way that we represent values coming from measured values in our calculations, making sure that they represent the degree of precision that is required.